Today we are going to discuss our fourth colligative property, that is osmosis. Okay, now what is osmosis? That is the net spontaneous movement of solvent particle from solvent side to solution side, or from solution of low concentration to high concentration is known as osmosis. Okay, let's discuss this. Now we have two diagrams. In that first one, in which on one side of the container we have taken a solution and on another side we have taken solvent. Okay, this is nothing but SPF. Full form of this is semi permeable membrane. Okay, you might have heard this word. What is meant by the semi-permeable membrane? Means they allow some molecules to pass through but does not allow other molecules to pass. Okay, means here solvent has a lower concentration. Let's assume for solution C1 and for solute C2. Definitely this is only solvent. So solution has a greater concentration than solvent. So solvent molecule can pass from semi-permeable membrane. Okay, so if a solution has this level, then definitely when solvent molecule will pass, this level will get rise. Okay, and this solution will get diluted. Okay, next. In this diagram, you can see clearly we have two solutions. Concentration of this solution is C1 and concentration of this solution is C2. Solution 1 is higher concentration and solution 2 has lower concentration. So definitely it will travel from low to high. Okay, you might have clear about this now. Okay, this is nothing but osmosis. Now let's discuss the difference between diffusion and osmosis. Osmosis applicable only for solutions, whereas diffusion is applicable to solid, liquid and gases. Here movement of only solvent particle will occur, whereas in this case solute and solvent both movement is possible. Not possible without SPF, semi-permeable membrane. Okay, such as here no role of SPF, so that is no need of this SPF. It can be reversed as well as stopped, that we will discuss later. Okay, this cannot be stopped or reversed. Okay, once you add the solute in a solvent, it will get diffused. Okay, you cannot stop this. Okay, so now we will discuss about SPM. That is a special type of membrane which allows the movement of only solvent particle through it. Okay, that may be a animal membrane or copper ferrocyanide. Okay, these two are the membranes. Let's discuss in detail about osmosis. Okay, this is a cellophane bag, okay, which is a definitely semi-permeable membrane. In this we have a solution 1 and in this we have a solution 2. Solution 1 has a concentration C1 and solution 2 has a concentration C2. If we can consider C1 is greater than C2, so this solvent molecule, these are the solution 2 molecule will enter into the solution 1. Okay, and due to this, what happens? This level will get rise. First the level is A and now the level is up to B. Okay, now the level is up to B. This is due to what? This solute 2 molecule. Already solute 1 molecule is present up to A and now there is a entry of solution 2. So this height will get rise. Okay, so this can be identify with the help of pi into rho g h. Now what is pi? Pi means osmotic pressure. Okay, so we will discuss at point B there is only atmospheric pressure. Atmospheric pressure. Whereas at point A there is a pressure of this B also. Even there is a pressure of this higher concentration solution 1. ओके दोनों का प्रेशर है ए के ऊपर. यहाँ पे आप देख सकते हो यहाँ से तो सिर्फ एटमॉस्फेयर का प्रेशर है. ए के ऊपर ये जो इंक्रीज हुआ लेवल राइज हो रहा है उसका भी प्रेशर है. दैट प्रेशर इज ड्यू टू द फिनोमेना कॉल्ड osmosis. Okay, and the pressure which is developed on this A is osmotic pressure, and that can be represented by the pi, and pi is equal to rho g h. Here this is the height, next g is the gravitational force. Okay, ये मोलिक्यूल को एक ग्रेविटेशनल फोर्स नीचे की ओर भी खींच रहा है, एंड रो इज द डेंसिटी ऑफ दिस सोल्यूशन. ओके, सो प्लीज note down each term what it represents. Next we will discuss if I want to fix this level. If I want to fix this level, this is a semi-permeable membrane, so definitely this solvent molecule will enter to a solution because solution has a higher concentration than a solvent. Okay, but if I apply the pressure over here and stop the involvement of the solvent molecule or stop the passing of the solvent molecules, okay, so we can fix the height. This pressure we will discuss. Extra hydrostatic pressure developed over a solution of high concentration due to phenomena called osmosis, and this pressure is known as what? Osmotic pressure. Hope you understand this very well. Okay, now we will discuss. So now we will discuss the formula to find the osmotic pressure. You know the formula, that is PV is equal to nRT. PV is equal to nRT. In this formula, if we keep instead of P pi, this indicates the normal pressure, that is for gases, whereas this pi indicates what? Osmotic pressure. So we can say pi V is equal to nRT. Okay, so pi is equal to n by V RT, and this is mole per liter, so that represent a concentration. So instead of this n by V, what we can write? We can write CRT. So this is the formula to calculate what? Osmotic pressure. Okay, so in next lecture we will discuss some numericals related to colligative properties, even the numerical which will come in your JEE NEET exam, that also we will discuss. Okay, this is the reverse osmosis. If external pressure greater than osmotic pressure is applied, the flow of solvent molecule can be made to proceed from solution towards the pure solvent. Okay, this is the fresh water, means it is a solvent, and this is a solution. Okay, so if we apply a forcefully pressure over here, that pressure is definitely greater than the osmotic pressure. Due to osmotic pressure, the solvent will travel to solution. But if extra pressure is applied over the solution, now solution molecules are now traveling to the solvent molecule. And that is the reverse direction of the ordinary osmosis. Reverse osmosis is used for the desalination of seawater for getting the fresh drinking water. Okay. Osmotic pressure solution can be classified by, first is isotonic solution. Isotonic solution. Okay, iso means same. Isotonic means what? the two solution which are having same osmotic pressure. Means a solution 1 has osmotic pressure pi 1 if solution 2 has osmotic pressure pi 2. Okay, what is the formula of pi 1? For concentration is different, so we can say C1 RT is equal to C2 RT. Definitely R is constant for both. If temperature is constant, then we can say C1 is equal to C2 for this. C1 is equal to what? N1 upon V1 is equal to N2 upon V2. Okay, so we can apply this formula if they will represent that the solution is isotonic with each other. Okay, now if pi 1 is greater, this is the second type. If pi 1 is greater than pi 2, so in comparison to pi 2, pi 1 is said to be hypertonic. Okay, and in comparison to pi 1, pi 2 is said to be hypotonic. Means which are having less concentration or less osmotic pressure are hypotonic, and which are having more osmotic pressure or more concentration are called as hypertonic.